Hi, welcome to my presentation about Spacechains. Spacechains are a combination of two ideas, one being the blind merge mining and the other one being the Perpetual One-Way Peg. And I'm going to go through both of them, and the combined concept is what I call Spacechains. So the key points are we're going to create some kind of blockchain, but we're going to do it by outsourcing mining to the Bitcoin blockchain with only a single transaction per block. Meaning that there's not going to be a lot of overhead on the Bitcoin blockchain. It's going to be a trustless chain, multiple trustless chains, as many chains as you like, that can be created permissionlessly, and they essentially serve the Bitcoin ecosystem. There's not going to be a competing coin, there's no altcoin, no shenanigans like that. It's going to function in a way that does not require a speculative asset. So this is hopefully going to open a door to more permissionless innovation, where essentially anyone can create blockchains that serve the Bitcoin ecosystem. So the main thing, the one caveat that needs to be said, is that this is not a two-way peg. So this is not going to be a system where you take your Bitcoin, you move to a space chain, and then you do your thing there and you move back. That is not going to be possible. So you might be thinking now, is this a sidechain? Well, that's a good question. I think depending on who you ask, the answer may be yes or maybe no. So I decided to answer this a little bit more in an indirect way and describing basically what part of a sidechain, kind of the sidechain idea, it does hit on. So obviously the one it doesn't hit on is there's no trustless two-way peg. But the things it does do is it allows permissionless chain creation without another speculative asset. And really, it serves the Bitcoin ecosystem. And I think that is one of the, at least half of the dream of what kind of the sidechain idea was all about. When the paper original released in 2014, at least that was what I was dreaming of. Having all these different chains where you can just move your Bitcoins back and forth. And now, okay, you can't quite move your Bitcoins back and forth, but we still have lots of different chains that somehow serve Bitcoin. So to kind of go through what a spacechain is exactly, I want to start very simple, but with a deceptively simple question, which is, what is a blockchain? And I think when you hear this question, you might think it's simple, but I think it's actually a difficult question to answer. So the way I want to answer this question is that it's an open database, essentially, but it's an open database that is rate limited by sacrifice. And in the case of Bitcoin, obviously, the sacrifice is proof of work. And the nice thing about Bitcoin is obviously that essentially anyone can create a block. If too many blocks come in at the same time or within a certain time frame, the difficulty goes up. So this naturally rate limits how many blocks can be created. And this sort of makes sure that even though it's an open database that anybody can add data to, there's never going to be too much data. There's only going to be roughly 2 megabytes every 10 minutes. So the interesting thing is that the resulting scarcity, at least in the way Bitcoin did it, can be tokenized because there can only be one block every 10 minutes. If you add a block reward there and you create, say, 25 Bitcoins every 10 minutes, and then, after a couple of years, 12.5, 6.25, etc., that's the way Bitcoin issues new tokens. And then once you have tokens, the system is kind of bootstrapped, right? We have a scarce token that everybody can use. But the one interesting thing that I think is quite underappreciated is that Satoshi Nakamoto came up with a way to do mining or leave it to other people to do mining. And the importance of that cannot be understated. You don't have to take your transaction and put it into your block yourself and mine it. But what you can do is you can just add a fee, and anyone can take it. You send it over through the P2P network, and anyone can take those transactions, put them into a block, and claim the fee for themselves if they're successful. And that's a non-interactive process. And that is really one of the key things that makes Bitcoin work. And maybe it looks obvious in hindsight, but I don't think it was that obvious. And it turns out that this is quite a key feature to kind of recreate yet another blockchain. You need to have a feature like this. So roughly what we're trying to do here is we're trying to create yet another blockchain or multiple blockchains. But we want to skip the tokenization step. We don't want to create yet another Bitcoin competitor, yet another altcoin. But everything else we kind of need, right? We need an open database that's rate limited by sacrifice. And we need some kind of way to outsource the mining, where we just send our transaction and somebody else puts it into a block for us. So these two features are basically what we're going to try and recreate. So first, creating a blockchain. How do you do that? Well, the mechanism I'm using here is called blind merge mining. And essentially you use BTC, you use the Bitcoin blockchain or use the Bitcoins to sort of simulate or emulate mining. And what you do, like with Bitcoin, you have proof of work, and that's a way to show that you sacrifice something provably. But now that we have Bitcoin, we can do it in other ways, right? We can say, okay, well, maybe I burn a Bitcoin, or maybe I lock up my Bitcoins, or maybe I waste a bunch of block space on the Bitcoin blockchain, which is a terrible idea. Don't do that, but it works. And this is my personal way I think this should be going, is through something called fee bidding. So fee bidding is, in my opinion, the better of these options, although they all can work to some extent. And the reason for that is that it's very space efficient and it's fully incentive compatible, where if somebody tries to censor you, it essentially works the same way Bitcoin works, where it's costly to censor somebody. And in terms of space efficiency, as I already told you, what we're going to get it down to is 1 transaction per block. So there's also regular merge mining, and I have to specify that this is actually better than regular merge mining, because with regular merge mining, what you need Bitcoin miners to essentially participate and run the software and create blocks for you. And here in this system, what I want to do is anybody can create a block and anybody can propose it to the miners, and the miners just take whatever pays them the most, basically in Bitcoin fees here. So how that works out is that the mining is completely separated from the Bitcoin miners. Anybody can do it, and the Bitcoin miners, they just do their usual thing where they just take the transactions with the highest fees. We'll get into more detail about how that works later. And just to give you a rough preview of what's going to happen, I'm going to give you kind of a simplistic overview, and then I'm going to go into the actual details, the technical details. So either way, you'll get your answers. So fee bidding, blind merge mining. What's that all about? Well, you can, at a high level, imagine there being a unique location for a blockchain hash in the Bitcoin blockchain. There's only one location. If you want to utilize it, you'll have to outbid others for it. So anybody can bid for this unique location by offering Bitcoin fees to the Bitcoin miners, and whoever pays the highest fee gets their hash included. So it's an auction, and the auction winner gets the block and therefore gets the block on this other space chain that they have created, presumably through this blind merge mining process. So the original idea, as far as I know, is from Paul Stortz. And he basically, the way he had envisioned it, it requires a soft fork. And what I've come up with here is a way to kind of avoid having to do at least a specialized soft fork. So you don't need a soft fork that literally is only in order to enable blind merge mining. You can even do it without a soft fork, but there are some sacrifices, and we'll get into that later on. But this kind of means essentially that now, since there's no longer a specific soft fork required, it's kind of inevitable. This is going to happen. So just to give you a better idea, let me show you with some pictures. Imagine the Bitcoin blockchain, and this little pink blob is this unique location that people have to bid for. So it's a hash, and the hash refers to a spacechain block. And the way consensus works is just the next Bitcoin block comes in, and then there's also another spacechain hash in there and referring to a spacechain block. So what's important to note here is that this blockchain can fork separately from the Bitcoin blockchain. So how that works is as follows. Here, for instance, another block 2 is found, block 2b, and it's mining on top of block 1a. So now you have a fork. Both are length 2, but we don't know which the winner is. And the winner is simply determined by literally which is the longest chain. So once another block is found, now we know the winner. 2A is orphaned, and 2B is essentially the winner. Of course, this could change again, but assuming consensus just moves forward, this is now the state of the network. So One way of looking at this, and I think it's an important abstraction, is to say that this is essentially like a single-use seal. And a single-use seal is a concept or an abstraction, an idea that was thought of by Peter Todd, where it's essentially the idea is that every UTXO on the Bitcoin blockchain is like a little box that you can open once. You can take out the content, you can put it in other boxes, but it's single use, right? You can only open the box once. And here we have kind of a similar concept, except that the box is not opened by whoever holds some kind of private key, but it's a box that literally can kind of be used or closing the seal, in this case is the analogy, by whoever pays the most to the Bitcoin miners and Bitcoin fees. And the reason I want to kind of point that out is because right now I'm using this for blind merge mining, but that's not necessarily the only use case. There are other ways in which this can be used as well, and I'll leave that to your imagination. So, roughly speaking, this process of having this unique hash and having people bid for it is roughly analogous to proof of work, except there are a few changes, a few differences, and they're relatively minor. So first, there's no difficulty, as you might have noticed. But it's not entirely true. Difficulty is actually inherited from Bitcoin because the Bitcoin blockchain ensures that it can only be one unique hash every 10 minutes. So this is essentially how the difficulty works out. And all the fees that go to the Bitcoin miners, they're also turned into proof of work. So they are part of the difficulty algorithm, essentially. So there's no difficulty in the blind merge mining side on the Spacechain, but there is an actual kind of difficulty that is inherited from the Bitcoin blockchain. So the second thing is, well, the highest bidder always finds the block. And that is somewhat different. It's kind of like, how would I say it? It's like hashing power is just like anybody can mine with any kind of CPU, for instance, where it's relatively easy to go to Amazon and rent a bunch of hash power. You can just take over a blockchain. It's kind of like that, where as long as you're willing to pay the most money, you get to create the block, but it is still competitive. So in that sense, it still works. And the interesting thing is that every user is essentially a miner, as long as they have some Bitcoins and are willing to pay some Bitcoins to create a block. So it creates a very competitive ecosystem. So forks are possible, but they play out sequentially. As we saw in a couple of previous slides, essentially, if you remember the block 2A, block 2B, when block 2B is created, block 2A is not being built on top of, right? It's not possible because there's only one unique hash where a block can be put. So even during a reorg, let's say you want a 100 block reorg, that means that the chain basically stands still for 100 blocks. And that's actually a good thing because it makes the reorg more difficult. To think of like low proof of work blockchains, where out of nowhere, suddenly 100 blocks can appear and be the longest chain, and you're just screwed, right? Like there's a reorg. And here, at the very least, you see it coming. You can respond by trying to build on top of the currently longest chain by paying higher fees, etc. So I think game theory-wise, it actually works out a little better in favor of having consensus move forward. So this is also kind of funny thing, but a minority soft fork or even a minority hard fork that is trying to utilize the same unique spot can survive because the only blockchain that will appear is the one that pays the most money, the most fees to the Bitcoin miners. So if you have two blockchains that are trying to compete for the same spot, the highest paying one simply wins. This can be good or bad depending on how you look at it. There's always a way to hard fork out of it by just picking a different unique spot. It has to be a unique spot, but there can be multiple. And finally, this also needs to be pointed out, is that you have to validate the parent, right? Or the parents, even if you have a space chain inside of a space chain. And the reason for this is that the parent is basically where the fees are being paid. And there's actually one more step that I'll get into later that makes a space chain, which is the Perpetual One-Way Peg, and that requires also the parents to be validated. So the main thing that is preserved here is the censorship resistance. Miners lose income if they try to censor anything. If they don't want to put your blind merge mined Spacechain block into the blockchain, they can do so. But if you're the highest paying person, they are losing fees. And if they're losing fees, they're not competitive against other Bitcoin miners. So it works out exactly the same in that sense. So that brings me to paying for block space. Okay, so we've got this blockchain now. And we have a mechanism, blind merge mining, to create these blocks. But now we still need a way to pay people to pay miners to put your transaction in, right? We don't have a token yet. Similar to what I was saying about Bitcoin, where that was quite the innovation, that you could use your Bitcoins to pay fees. How do we pay fees here? So what are our options? Well, the simple but rather silly solution would be to create an altcoin, right? And as I said earlier, we don't want to do that. So that's a no-go. A cool but way too complicated idea. Maybe someone can think of some way of doing this properly, but it is, I can tell you it's quite difficult, is pay out of band, where you essentially maybe pay over the Lightning Network or something along those lines, and then your transaction, you pay the miner and the miner adds the transaction. But the problem with this is that it's very difficult to make it so that these two are kind of synchronous, right? Where there are multiple miners, and now how do you know which one to pay? How do you know that after you pay them, they actually put your transaction into the block? These are all problems. So long story short, it is, at least as to my current knowledge, too difficult to make this happen and not really practical. So that brings me to the third and final solution, which is burning your Bitcoins. And this is actually an old idea that I kind of brought back to life, and it turns out that it works better than you might expect. So let's get into that. But before, I just want to say that because we don't have a new token being created, we don't have a block subsidy. So the reorg incentives are different than how it works out with Bitcoin, right? With Bitcoin, we still have a block subsidy, but once that goes down to zero, now the reorg incentives are a little different. So we basically run into that problem sooner here. And that's important to point out. It's not a trivial problem to really ensure that the blockchain moves forward, but it is definitely a solvable problem. So at the very least, it's not a showstopper. Okay, so the burning Bitcoin part, which I call the Perpetual One-Way Peg. One-way peg meaning, as opposed to a two-way peg, you can move your Bitcoins to this other chain, but one way, so you can never move back, which is why it's a burn, right? You destroy your coins and you get some Spacechain tokens. And it's perpetual, meaning that you can always do this. So for every Bitcoin you burn, get a space coin. This preserves the 21 million limit, essentially, so that's great. There's not, seeing the whole Spacechain plus Bitcoin ecosystem still preserve the 21 million limit, I think is a very important aspect of this, right? Where there is literally no inflation. So this is important to note as well, which is that Bitcoin is always a superior asset. It's absolutely not a competitor. If you move from Bitcoin to some kind of space chain, now you're stuck in a space chain, you can't go back. But if you just hold your Bitcoins, you do nothing, you can always move to a space chain later. So that's always a superior option. There is really very little incentive to actually burn your Bitcoins and move over, but there are some, which I'll get into. The token essentially has only one use case, and that's what I wanted to say, which is that you only use it to pay for block space. That's literally the only use case. So the way it works out is that you essentially you burn a few Bitcoins or Satoshis, whatever, get some space Satoshis, space coin Satoshis, and those are the only thing you use to pay for fees, pay for block space. And I'd say the most important thing here is that there's really no meaningful speculation you could do with this token, right? It's never going to be worth more than a Bitcoin. So why would you speculate on it? Why would you move over to this chain more than you actually need? So what's most likely going to happen is that you're just going to see roughly how much block space demand there is. So let's say there's, 1 Bitcoin worth of block space in terms of fees every couple of blocks or something like that. Then there really will be only 1 Bitcoin burned in total, and that will be sufficient to pay for all the fees for everyone essentially on this chain. And it's going to be kind of a loop, right? Where the blind merge mined Spacechain miners, they get the fees and they sell the fees again, and then you can use them again etc. So that's kind of where you have your, either through the Lightning Network or whatever, when you need some space coins to pay for fees, you just buy them, or you just hold a little amount, like $5 or $10 or whatever, depending on how popular the space chain is and how high the fees are. So that actually, because it's so uninteresting to speculate on this token, it actually creates a lot of stability for the token, where the only way the token kind of loses value is there's a lot of demand for block space, and then the demand for block space goes down again. Then the token goes down in value a little bit, but even that's not too important or too problematic, because you're not supposed to be holding a lot of these coins, right? So maybe you had $10 worth of the space chain coin, and then, okay, now you have $5. Okay, yeah, it sucks, it's not great, but you can still utilize the chain for its utility. Nothing is really lost except for like a little bit of value, which was not supposed to be worth much in the first place. Fernando Nieto, I'm not sure how to pronounce it, he wrote an article which is called Soft Pegged Sidechains, where he goes into some more details, and I also post in the comment section. So if you're interested in kind of the topic of how to maintain the peg stability, at least somewhat, you can find more information there. So, and this is important to note, there's a real limitation here, right? Like, this is not a token where you're going to store your value. It literally cannot act as a store of value. You'd be crazy to move in $1 million into a space chain and expect to get your value back somehow when you sell the token to a third party. That's never going to happen. So that is the one limitation, where the only use cases for these chains are things that do not require you to have a store of value on there, or decentralized store of value, I should say. So that might raise the question, well, what are these chains good for if you can't store value? Well, we're going to get into that. But first, I want to mention that I think a lot of people have this feeling where, wait a second, you're asking me to burn my Bitcoins? That really feels bad, man. I don't want to burn my Bitcoins. And yes, I understand the feeling, but it really isn't bad, is all I can say. It's a feeling, and you should get over it because it's not logical, and I'm going to explain why. So first, the alternatives are worse, right? You could have some competing altcoin if you prefer, and then you don't have to burn your Bitcoins, but now you have to sell your Bitcoins to get the altcoin. Is that better? I don't think so, because that's not a chain you want to use, right? You don't want to use Ethereum, you don't want to use Dash or whatever. You want kind of the value in the ecosystem to be with Bitcoin. And that's really kind of a key thing here that this whole idea is trying to accomplish, where it's supposed to build the Bitcoin ecosystem, not create competitors for Bitcoin. You could also have some kind of trusted IOU token. You could have a USD Tether chain or something, and I have an example of that later on in the presentation. But that runs into the issue of that you're trusting an entity, right? And that's the whole thing we're trying to avoid here. We're trying to be trustless. So these are not better alternatives. There really isn't an alternative, actually. This is really as good as it gets in terms of avoiding these much more massive problems. So, second thing that unfortunately isn't obvious to everybody who hears this, but you don't have to burn your Bitcoins. Somebody has to burn their Bitcoins. And then once that happened, they can sell those tokens, those space coins to you. So you can buy them from somebody who already has space coins, or buy them from space chain miners who receive them whenever they create a block. And that can be sufficient. So it's not necessarily that everybody burns some Bitcoins. It needs to happen to a certain degree, so there are some tokens on this chain, and then that's sufficient. And so this is something I mentioned already, but it's good to repeat it, which you really only need to burn as much as there's block space demand, right? There's one Bitcoin demand, one Bitcoin worth of demand, basically, then only one Bitcoin needs to be burned. That would be sufficient. There's going to be some friction in the system where obviously you're not going to get, you create a block, and then the miners get the space coins, and then they sell them on the market again, and then the next block appears. Maybe it's possible to create really efficient markets where that happens instantly. I don't know. But my guess is that, there's going to be a little bit of friction there, and people are going to hold on to some of these space coins a little bit, but not to a massive degree. And finally, it's just good. I mean, what this means is that other people are going to be burning their Bitcoins, which means your Bitcoins are going to be worth more because they're more scarce now. So really, it's good for Bitcoin, right? If half the Bitcoins disappear tomorrow, it means your Bitcoins should be worth twice as much. And that is how that works. So really, there is no downside here, right? You don't have to burn your Bitcoin. Somebody else can do it. There doesn't have to be a lot of Bitcoins burned. And if Bitcoins are burned, I'm not complaining. I think it's great, right? More Bitcoins for me, basically, in terms of relative value. So that brings me to the use cases, and that's not an unimportant thing, right? So far I've talked about this. Okay, so we've got a blockchain, but it can't store value. There's no two-way peg. So what the hell is this good for? And that's a really good question that maybe I should have answered a little sooner, but I'm answering it now. And I think the main use case, or at least the one that I think connects to the most people, is essentially colored coins. You could have colored coins with privacy features or something like that, so asset issuance. So once you have this chain where tokens can be created, and these tokens can be anything. They can be rare Pepes, they can be whatever if you want to do security tokens or something. I'm not a big fan, but sure, go ahead. You can even create a token that is a federated two-way peg, where it actually represents Bitcoins, but obviously there's a trust. There's a trust involved there, where whoever issued the token is actually promising you that you're going to get a Bitcoin for the token, similar to the Liquid network. But it's possible, and people can use it in that way, where you kind of have a hybrid of people issuing tokens on this trustless decentralized chain, and then the tokens themselves might not be fully trustless, but that's up to you to decide whether or not you want to hold that token. And of course, it can have privacy features. It could be a Mimble chain even, or it could be like Liquid, where it has confidential transactions. You could do decentralized DNS, and this would essentially replace Namecoin, where with Namecoin, you basically have the functionality of decentralized DNS, but I think the existence of a speculative asset inside of a chain such as Namecoin is a problem. And not to say that Namecoin had a better solution back then, like we didn't have a better solution to the problem. So it's completely understandable that they created an altcoin. But I think for today, looking at that, the altcoin only adds friction, right? It only adds pumps and dumps, meaning that your coin might go heavily up, heavily down in value. And you don't really want that, right? You just want to utilize the chain. You just want to have DNS. So the existence of the speculative token, I think, is a complete negative, and we can get rid of that essentially and reissue something like Namecoin, take out the speculative asset and replace it with the Perpetual One-Way Peg and use blind merge mining. So even all the mining fees kind of go to the Bitcoin network as well, which also helps Bitcoin to become more resilient. So then the third use case, and I think this one is a bit of a stretch, but it might be possible. I'm not sure. It's weird. Which is low value payments, right? So essentially think of, kind of the Bitcoin Cash dream, right? Where the idea was, well, we want our low value payments on the blockchain. Blocks should never be full. Transactions should always be cheap. So you could do that, provided everybody is willing to hold like $5 to $10 worth of these space coins. Not a lot of value. You don't really care whether it goes down in value a whole lot. And then you use that to create small transactions, but on-chain, on a bigger blockchain that you don't have to use if you don't want, right? It's an opt-in chain. So it really provides kind of the Bitcoin Cash use case. The only thing that's questionable is whether the token really holds any value. So you'd have to think like, okay, so let's say if you're receiving a lot of these microtransactions, after a while you have like $100 of them, well, you better cash them out quickly, right? Because it's not really a place where you just want to keep gathering and suddenly you have like thousands of these tokens, because by the time you want to sell them and a bunch of people want to sell them, then the value might go down. So you got to be careful there. But I do think it works at least like to a lesser degree, right? For maybe really small payments, as long as blocks are not full, and you can maybe experiment a little bit with more dangerous chains that have way too big block sizes. And then finally, you can have DAOs, you can have DeFi, you can have DEXes. I'm going to give a more like specific example of kind of what kind of use case you can have there. But for DAOs, for instance, I know BISC has a sort of like a colored coin DAO that's currently operating on top of the Bitcoin blockchain. I think that's going to be a problem. When Bitcoin blocks become fuller than they are now and transaction fees go up, something like that just can't exist efficiently on the Bitcoin blockchain, and we'll have to move. And I think this is kind of the place where we have to move. And then the DeFi, the DEX stuff is kind of like the Ethereum use case, or like the stuff that they're doing. Some of that, I think, can be tied to Bitcoin through these chains, and we'll get into that later. So that brings me to the technical details. So from this point on, it's going to get a little bit more difficult to follow. Hopefully, you can still kind of follow everything. I'll try to keep it as straightforward as possible. And at the end of the presentation, I'll give you a couple more kind of use case examples, a little bit more like practical. So please stick around for that. Okay, so under the hood, first a few technical things, and then I'll show some pictures. So bear with me. So essentially what we're creating is a sequence of transactions. They're enforced by a covenant, and there's a relative lock time of 1 block. So you just have a bunch of transactions, and 1 transaction per block can get into the blockchain. We use SIGhash anyone can pay plus SIGhash single. And what this does is that we have this kind of input and output that marks the covenant, and then we have other inputs and outputs that come from users that they can add. And they add them to pay for fees, and they add them to add their blockchain Spacechain hash, basically attach it to this transaction. It's RBF enabled, and that means that anyone can pay for inclusion. So you have to basically outbid each other, and that's how we get the fee bidding. And so the Spacechain block hash can be committed in the added output, but we can do this through basically the equivalent of the Taproot commitment. It doesn't have to be exactly the same, although it could be. And what that does is that basically even the hash doesn't appear on the Bitcoin blockchain, so that saves another 32 bytes. It's not absolutely necessary. You can also just use an up return, but it's more efficient. So there will be even more details later, but here are some pictures. So imagine a transaction here with a covenant input, a covenant output, and we'll get into the details of the covenant later. So the user adds their inputs and outputs, and through RBF bidding, essentially, this determines who gets to add their input and outputs. So let's say you put 1 Bitcoin as a user input and then 0.95 as a user output. That means you paid 0.05 Bitcoin as a fee. And then somebody else comes along and they pay 0.06, which is higher. And therefore, your transaction doesn't get in, but the other guy's transaction does get in. So the highest one, let's say 0.06, gets mined into a block. So now with the user output, they reveal their Taproot commitment to the peer-to-peer network of the Spacechain, including the whole block itself. And that's basically how the Spacechain block comes into existence. So in the Spacechain block, there is a user Coinbase, which is where they aggregate their Spacechain fees. So they get all the fees on the Spacechain, and that decides basically how much they're willing to pay on the Bitcoin side, right? So in this case, 0.06 Bitcoin means that on a Spacechain, they should have received roughly the equivalent of that. So once the next block is created, it's exactly the same thing, right? Same covenant. The covenant is also connected, right? So the covenant output is the covenant input for the next transaction, and everything else is exactly the same. So it just repeats over and over. So that brings us to the question to how to do the covenant. So there are a couple of ways of doing it. So one way would be kind of a trusted setup, and this would use child pays for parents. The nice thing is that this trusted setup works today. I say trusted in quotes because basically what it is where you have the covenant input and output. You could just have a private key and you could just put a signature there. And you can then, after you created a bunch of signatures and all of these transactions, like 10,000 or a million of these transactions, you just throw away the private key with which you created this sequence of transactions. Then, assuming you really did throw away the key, it is as good as a covenant. But that's where the problem is. You don't know if the key was thrown away. Well, the nice thing is it doesn't matter a whole lot. It's not a good thing, and there are better ways of doing it. But if you want to do it without a soft fork, then that will be the way. The downside is that, let's say that person didn't throw away the key. They can then basically fork this sequence of transactions. And what that means is that the chain just halts. So nobody loses money. There's not going to be any reorgs or something weird like that. The chain halts, and then a hard fork has to occur to restart the chain. So it's not terrible, not preferably this doesn't happen, but nobody loses any money essentially. So that's why I think it's acceptable to do it like kind of as a first step. But we can do better. So one of the better ways would be check template verify. This would also require child pays for parents, RBF as well, by the way, both of these, but child pays for parent as well. And while that is one way of doing it, and this is Jeremy Rubin's idea, so this is a soft fork that is kind of in the works that may or may not come to Bitcoin. I think this is absolutely a perfectly fine way of doing it, but my preference goes to using SIG-hash anyprevout. And SIG-hash anyprevout is actually a soft fork that is, I think, maybe slightly more likely to make it into Bitcoin or might come to Bitcoin sooner than check template verify, but who knows. And it's actually intended for kind of improving the Lightning Network through something called L2 ELTOO. And it actually turns out that for this specific covenant that I'm trying to create, it is slightly more flexible than check template verify. So check template verify and SIG-hash anyprevout, turns out they can do roughly the same thing. Check template verify is usually the cleaner way of doing it. But in this case, I think there's an argument to be made for SIG-hash anyprevout because basically the transactions become a little smaller and things are a little bit more flexible. And we'll see that in a minute. So I'm going to go and take you through the SIG-hash anyprevout method of creating this covenant. And this, so I'm starting really simple here. And I guess I should note this kind of SIG-hash anyprevout was not intended to do the covenant, but it just turned out that it happens to enable this. So it's actually kind of cool. And this is something that Anthony Towns taught me. So I'll take you through it, kind of how it works. So imagine just a regular output, a very simple one where just a pub key and a check sig. So the way to spend this would be with a signature, right? So when you spend it, you just put the signature in the input script. And the signature signs the transaction it's signing and the transaction it's creating and the previous transaction is trying to spend, essentially. So what happens if we take the signature and we just move it, right? We just move it to the output script. So there is a problem here. This doesn't actually work if you just do this. And why doesn't it work? Well, there is a circular reference here, right? As I told you, the signature is signing two things, and basically the red bars you see here is what it's signing. So it signs a new transaction, but it also signs itself, and that becomes a circular reference, right? The signature itself is signing the signature, and that doesn't work. So the way to solve this is, well, that's exactly what SIG-hash anyprevout does. What SIG-hash anyprevout does is it allows you to skip signing the transaction ID. So you're not signing the actual transaction that you're spending. You're just kind of assuming that they fit. And with this, we've basically we've solved the issue, the circular reference. And now it actually works out, where you already have the signature of the next transaction in the previous transaction. And that makes it a covenant. So now that it's a covenant, we don't really need K there. We can just replace it by G. G is the generator. It's just basically your private key is 1. That's what it means. So there is no real private key there, but in order to stay compatible with how Bitcoin works, we do need to have a key there. So the key is just private key 1. Great. This makes creating the signature really easy because it's basically just a hash plus 1. There's no calculation needed at all. And yeah, this just works essentially. So we just create a sequence of transactions like this with the signature already in the output. That means that it's already determined what the next transaction is going to be. And that's how the sequence is created. And from this point on, we add the user input and user output. And the nice thing is that the SIG-hash anyprevout does two things. Because the TXID is not signed, it also means that the TXID doesn't change when a user adds their input and output. Or rather, it does change, but it doesn't matter. It doesn't invalidate the signature. So that works out perfectly. So here, it's important to note that the user input does sign the entire transaction and doesn't do SIG-hash anyprevout or something like that. And the reason for that is, well, SIG-hash, I'm not sure if that matters specifically, but what you need is you need to make sure that the entire sequence of transactions can't be replayed. so that people who were bidding but didn't get into the blockchain then still get into the blockchain, but in a way that's not actually a valid block. So that's not possible because the entire transaction is signed. So the TX ID at that point for at least the user input and output is basically determined and cannot change. So this prevents further malleability. So the Spacechain hash is basically the chain's output. So you can think of like a taproot output where inside of the taproot commitment, there's also a Spacechain hash that needs to be revealed at some point. And this basically lowers the burden or moves the burden of revealing a hash onto kind of the Spacechain side and makes the impact on the Bitcoin blockchain as minimum as possible. So that brings me to describing what essentially would be a minimum viable space chain. So if you wanted to create a space chain, what's the minimum amount of work you could do to get it to work today? So I would say you take the Bitcoin code base and you introduce some minor changes, relatively minor. So the first change you have to make is the proof of work. So you take the proof of work and you just keep it, but you just make it so that any amount of proof of work is valid. So nobody actually has to do any proof of work to create a valid hash. It's just difficulty set to 0. So then on the Coinbase reward side, you have to do two things. One is the regular thing you always do, which is you just take the Spacechain fees, which is fine, right? There's a token in this instead of Bitcoin, it's a Spacecoin. If there are fees, they go into the Coinbase. That's absolutely fine. But then the second thing you have to do is you have to take however many Bitcoins were burned on the Bitcoin blockchain. And the way this works is that you would just introduce that into this transaction structure here, right? Where you add another output with an op return. Op return doubles as a way of burning Bitcoins. And however many Bitcoins were burned inside of this transaction, they basically become a Coinbase reward on the side of the Spacechain. And then since we're using the op return for burning anyway, and it's a little bit easier, so you don't have to reveal the hash, although you might as well do the hash reveal thing. It just makes things more complicated. We're talking about an MVS, right? A minimum viable space chain here. You just use op return to put a 32-byte hash there. Not the most efficient thing, but it's the simplest way of doing it essentially. And then finally, since we don't really want to wait for soft forks, and that's something we've seen, right? Soft forks are taking quite a long time to activate. So instead of waiting for them, I suggest we just use the trusted setup today. Even though it's not perfect, it's good enough, right? At the worst case scenario is that the chain halts and has to be hard forked to be restarted. But it's not terrible, and it only happens if the person who created the sequence of transactions doesn't throw away their private key, which I think is also, there's not a whole lot of gain there to keep the private key. So it can be acceptable. It's not ideal, but if we want to get started today, that's how we have to do it. So for this reason, I think it's good to show you what this kind of like trusted setup method looks like. So this is what it looks like. I'm not going to get into detail, but essentially, instead of having one transaction in the Bitcoin blockchain, you now need two transactions. The second one, child pays for parents. The first one and the second one can be RBF'd. That's roughly how it works. So it's the same thing. It's just more transactions. So that brings me to kind of a more, elaborate example, right? So I've given you an example here of like a minimum viable chain, but that's sort of boring. So let me give you a little bit more of a spicy example. So this will be a USD Tether or whatever, whoever wants to issue USD, can be anyone, kind of a DEX space chain. So the first thing to note is that, and this is something kind of interesting that Shores Provost actually mentioned to me, and I hadn't really realized until he pointed it out. But if you have a space chain that is specialized in existing for the use of one single token, like USD Tether, then you don't actually need the Perpetual One-Way Peg, right? It's not perfect in the sense that, okay, so you have this, this token that's not trustless, so the whole chain is kind of not entirely trustless, but you still have this, the way the blockchain moves forward is still completely, that part is trustless, right? So there's still a benefit to doing that. So in the case of having a USD Tether chain, which is really exclusively for that purpose, you don't need the Perpetual One-Way Peg. You just issue USD Tether and you use that to pay for fees to the miners of this chain. So then one thing you can do is you can create a Bitcoin derivatives covenant. And this can be done trustlessly without an oracle. And the reason for that is that, as I mentioned before, if you run the Spacechain, you also have to run the Bitcoin blockchain. And what that means is that you can have consensus in the Spacechain be dependent on what happens in the Bitcoin blockchain. And that's really nice because that allows us to kind of do something along the lines of sort of like like an atomic swap that is semi-native, but only like halfway because it's only like on the Bitcoin side. And this allows us to create sort of it's not quite a two-way peg, but it's a way to have a something that is like the value of Bitcoin inside of this USD Tether chain. So I'll get into the exact details in a second. So then once we have this USD Tether and we have these Bitcoin derivatives, at that point, you can swap them out, right? You can just trade with those. You could create like special trading contracts like what they do in Ethereum or something like that. All of that stuff. So the Bitcoin derivatives covenant, what does it look like? So here you can imagine a contract. So this is going to be a transaction, right? A contract representing, let's say, 1 Bitcoin. And for the current example, let's say 1 Bitcoin equals $20,000. So Alice, who is basically the contract facilitator, and normally she would receive a fee for that, but we're leaving it out for simplicity. She puts in half a Bitcoin worth of USD Tether, so 10K. And then Bob, who actually wants to have this contract, he wants to have the Bitcoin, so he's the one paying the fee. He puts in 20K, and 20K is exactly what 1 Bitcoin is worth. So on the output side, there's 30K in total, obviously. So the question is, who gets the 30K and when? So the first condition is if Bob receives 1 Bitcoin on the Bitcoin blockchain, and remember, like I said, this can be verified, right? The Spacechain is aware of what happens on the Bitcoin blockchain. So if this actually happened and Bob received a Bitcoin, then Alice can claim the full 30K. So she gets her 10K back and the 20K that was originally the price of the Bitcoin. So the second way in which this can end up is there's a timeout. So Bob never received his 1 Bitcoin and just nothing happened, and Alice was just lazy and did nothing. Then Bob can get both the 10K, which is essentially collateral, plus the 20K he put in originally. So he's 10K richer, essentially, depending on what the Bitcoin price is, but that's what the collateral is for, to kind of have enough there that even with a price swing of 50%, you're still fine. So the third thing you can do, which kind of makes it more of a token, is that you can create a covenant out of it, right? Where you can allow Bob to swap out. So everything in the contract stays the same, but everywhere where you see Bob, now it says Carol, for instance. So Bob can sell this contract worth 1 Bitcoin because he's going to get 1 Bitcoin towards the end of the contract. He can sell it to Carol, and then everywhere where it says Bob, it now says Carol. So that essentially tokenizes this contract. And so one thing he can do is he can even sell it back to Alice, right? And then Alice never actually has to give a Bitcoin because Alice just holds the entire contract at that point. So because of that, it doesn't have to end up that Alice even gives a Bitcoin to Bob, right? You can end up by just settling, which is kind of like the cooperative close in a Lightning Network, right? Where you don't really want everything to play out. You just want to agree that if it plays out, you know how it's going to play out. So you just pay each other and you're done with it. So one last caveat that I have to point out here is that there's a race condition, which is that Bob can transfer the covenant to Carol while Alice is paying Bob 1 Bitcoin. And in order to prevent that, you actually need Alice to be able to first disable the covenant, whether you want to do that temporarily or not, that's a design detail. And then at that point, then you give the Bitcoin. And that ensures that this race condition doesn't occur. So that's kind of a cool way of, even though it's not a real Bitcoin, it's still like Bitcoin, and some people call that a sidechain. I don't think it should be called a sidechain when something like that happens, but you could call it that. So it gives you a glimpse into kind of what is possible, and there's probably far more than I thought of that is possible because you can create any chain you want, and that's really awesome. So just to give you kind of a potential future idea of like where this could potentially be headed, and obviously I don't know, but this is what I imagine would be good for Bitcoin. So you have the Bitcoin blockchain, roughly 2 megabytes. I know it's like 4,000 weight units or something like that, but roughly 2 megabytes worth of data. So then you have a space chain, which let's say utilizes the exact same code as Bitcoin does. Reason for that being that we want people to feel secure in using that chain. And then from that chain, you create your other chains. And this is essentially to minimize the amount of Bitcoin space you use. And maybe you create a big blockchain like we talked about with 32 megabytes worth of data or something like that. And what you have here is on the Bitcoin blockchain, there's only one transaction per block, right? And that creates the space chain. And then from that space chain, we have the exact same construction creating the big block space chain. So it's very efficient in terms of how much Bitcoin space you're utilizing here. So then maybe you have a confidential asset space chain, which maybe make it a little bit bigger because, I don't know, we feel like that's good enough. And in this chain, you can create your own assets. They can be confidential, so you don't really see the history of it. Somebody could issue a federated two-way peg on there if they feel so inclined, etc. So then we maybe have to use the tether chain that I just described, where you have some sort of DEX thing allowing people to basically use the tether to move in and out of fiat without using an exchange. And then we might have some kind of experimental sidechain technology that does something weird where there's actually one chain that connects to some other chain, a bunch of other chains maybe, in a way that doesn't require you to validate all the chains, only the chains you're interested in, but still somehow you have some kind of two-way peg between them. And I may or may not be working on an idea like that, but that will be for another presentation. And then maybe finally, you will have some kind of DNS chain where maybe it's like a .com or something, where you store your URLs and you sell them onwards to other people. And what you can do is you can kind of you can chain these chains. And as I said earlier, what happens is that the children always have to validate the parents. So DNS number 3 is kind of, you have to validate DNS number 2 and DNS number 1 and the space chain in the middle and the Bitcoin blockchain, all of that. So it becomes kind of like a lower tier DNS essentially. So you can think of, maybe there's a DNS all the way to the end that only Bitcoiners use or something. And then DNS number 1 is maybe like the .com of DNS, something like that. Whether that makes sense to tier it like that, I don't know, but I just wanted to show it as an example. So that brings me to the end of the presentation. So in summary, space chains enable new blockchains that serve the Bitcoin ecosystem. Hopefully I've convinced you of that. And this is really something. So I guess maybe it's good to end on a note and say that the way I look at Bitcoin is that it's a resource that is really scarce, right? We have one block coming in every 10 minutes. It's only a couple of megabytes. Not a lot of data can get in there. And we have to find ways to do more with that space, right? Without just putting everything in a single blockchain or without just adding trusted third parties. So even though this kind of system with these blockchains, there are some limitations, I think it's a novel set of trade-offs where it is completely trustless, but it has some use limitations, such as there not being a two-way peg and things like that. But I think it's really where we have to go as an ecosystem. And, if not today, then maybe 5 or 10 years from now. I think having chains like this just makes sense, right? Where it's completely trustless and you can move to them and you can do your colored coins there. Take RGB, for example. I think it's a really cool project, but it still utilizes the Bitcoin blockchain directly. And as block space becomes more scarce, I think those kinds of use cases become priced out. Right, where here you can create a, let's say USD Tether blockchain, where you can still have cheap fees because you can even create 10 USD Tether blockchains if you wanted, as opposed to doing USD Tether as a colored coin on the Bitcoin blockchain, where if you want to move your USD Tether, you have to pay really high fees because the Bitcoin block space is so scarce. So that's roughly kind of my thinking. My feeling is that we have to move towards things like this, and that's also what motivates me to work on this. So yeah, that concludes my presentation. Thank you very much for listening. If you're interested in talking more about this or just discussing it with me or whatever, please join me on Telegram at a channel I created called t.me/spacechains. So you can go there, you can chat with me and other people who are interested in this on Telegram, and maybe we can discuss kind of what this potential future for Bitcoin might look like. Thank you.